Okay, welcome everyone. Welcome to the 4th annual Moon over Merrimack. We're so excited to have you on board. We have quite a week for you all tonight, Wednesday night, and Thursday night. And as it's so exciting because Moon over Merrimack is happening as that big, beautiful gibbous waxing moon is rising right over Merrimack right now. But we have our first speaker this week is Piyush Khopkar, and this is his 4th year with us, which is pretty incredible. Piyush is serving as one of NASA's JPL Solar System Ambassadors since 2015. He's part of the MOXIE and the Mars 2020 Perseverance Rover mission team. And as part of this MOXIE team, he gets to operate MOXIE on Mars. He's so proud to be part of the MOXIE team and helping in generating the first ever oxygen on Mars. He's worked as a software engineer by profession and holds a Master's of Science in Electrical and Computer Engineering from the University of Missouri at Columbia. And with that, and to let you know too, our Moon over Merrimack this year, it's part of STEM Week for Massachusetts, but it is also sponsored by the School of Education and Social Policy, as well as the School of Science and Engineering. And it's also co-sponsored by the President's Initiative for Diversity, Equity, and Inclusion. With that, Piyush, it's all yours.
Thank you so much, Anne, for that nice introduction and having me again in the 4th year. So let's do a quick check if everything is working. So yeah, so I'm actually going to talk about the Perseverance Rover and one of the instruments called MOXIE. I'm going to talk about that instrument specifically because I'm part of that instrument. I'm part of the team that operates and that built that instrument. And then I will be going a quick overview on the new James Webb Space Telescope, which is actually scheduled to launch in December. So let's see. So initially I thought, because I kind of presented about the Perseverance Rover and MOXIE earlier this year as well. So initially I thought, maybe I'll just give a quick update on where the rover is and maybe I'll just start with that. But then I thought, no, let's do a, let's go through everything. And if, let's say, if anyone has not attended the talk earlier, so I think it would be beneficial for them. All right, so let's begin with the basics, first thing first. So Mars. So again, my talk is, as I mentioned, I have divided into 2 parts. The part first is the Perseverance Rover and MOXIE, and the second part is the James Webb Space Telescope. So starting with the Perseverance Rover, so we'll start with Mars facts. So it's the 4th planet from the sun. Mars has 2 moons, Phobos and Deimos. Gravity, it has 62.5% less gravity than we have here on Earth. Atmosphere, it is compared to Earth, Mars has 96% of carbon dioxide and very, very trace of oxygen and other gases. 1 year of Mars is approximately double that of Earth, so it's 687 days. And 1 Martian day is called as 1 Sol, which is approximately 40 minutes longer than Earth day. What you are seeing here, what you're seeing here in this image is it's an image taken by the Curiosity rover, which kind of shows a sunset on Mars. Let's see. So the history, or the motivation of the Mars 2020 mission goes like this. So there have been numerous Mars missions in past, starting in 2001. Orbiters and landers on Mars that have actually followed water. And the way it works is you send something and then you learn something from it, and then you send something on top of it, because what you've learned. So you learn something from one mission and then you build something on top of what you've already learned. So there is plenty of evidence that water actually flowed on Mars in the past. So Mars might have looked like something like this in past, and it looks something like this in present. And we know that the planet was wet and habitable, and Mars has all the building blocks of life. But what we don't know is, did Mars ever have life? So again, when I'm not a planetary scientist, or I'm not into planetary science a lot. So, but it took me a little, like while to understand the subtle difference here. So again, like we know that Mars was wet and habitable, and we know that Mars has all the building blocks of life, or the things you need to have life, but we don't know if Mars did ever have life. And that is what the goal of the Mars 2020 or the Perseverance rover mission. So understanding the possibilities of life on Mars. So it has few objectives, like one is the geology, one is the astrobiology, understanding if life ever existed on Mars. Sample caching. So this is, like preparing for like more advanced mission where the rover is actually going to, well, not will Noah actually did collect two samples, and then the idea is to collect the samples, put them in a tube, and then drop them somewhere on Martian surface. And then the idea is like a future Mars mission would, like collect the samples and bring it back to Earth, because on Earth we can do more science and we can more understand deeply, like uh, and like make more discoveries. And the fourth objective is preparing for humans. So in order to prepare for humans, there are multiple things on the rover. So one is, like when humans are on Mars, so we would, number one, we would also want to know like how is the weather is changing, because I mean, like we would want to prepare ourselves. So how does the weather change? How does the temperature vary, or how does the pressure vary, or like how are the dust storms on Mars? The other thing is preparing for humans is, like we need oxygen for coming back and also for breathing. So MOXIE is one of the instrument about the rover, which um, is basically geared toward that. There is one more thing on this rover is, it has like samples of the space suits. So the idea is like, over the period of time, we would take the pictures and we would see like how the the material is, like it's changing, or how the surface of that material is changing, and to understand like more about like what kind of suits would be suitable for astronauts. So in short, doing more research on the clothes, the spacesuits, which eventually an astronaut will wear when they are on Mars. So the rover landed on a place called a Jezero crater. This is how it looks like from, like, this is the image from one of the orbiter. Um, if you're curious like how is the weather on Jezero crater, so it's around 21 degree high Celsius and low is 78 degree minus 78 degrees Celsius. So it gets pretty cold, and high is not that high basically. Uh, and this data is taken from one of the instruments called MEDA. So that is kind of a weather observatory or weather station, weather monitoring station on the rover. So we get data from the MEDA instruments every day, like about the temperature, pressure, and the density, and everything. Uh, there are 7 scientific instruments about the rover. Uh, MOXIE will talk about that in few slides. RIMFAX is the radar, subsurface radar. Mastcam Z is the panoramic zoom cameras. SuperCam is a laser. MEDA, I just spoke about. It's a weather station. Sherlock and Pixel are the spectrometer on the arm of the rover. And it has 23 cameras. Few of them here are like the Hascams are the hazard cameras, rear and front. The Sherlock and Pixel has context cameras. Um, like humans, we have 2 eyes. Similarly, rover has 2 eyes. So the right navigation camera, the left navigation camera, and there are a few cameras which kind of did record the landing. So I have the link at the end where you can actually see the rover landing in action, real on Mars. Uh, one more. Another thing is the rover has microphone, so you can actually hear the sounds on Mars. So let me try this. Can you hear that that windy sound? If you can hear, can you just maybe like one of you can just raise the hand? Let me play it again. Okay, thank you. So yeah, so from the sound, uh, so sound has a completely different science, because when the Mars has very thin atmosphere, and by thin, so that kind of changes everything, even when we hear. So by listening to the sounds on Mars, we would uncover like a lot of unknown things which we didn't know about, and that is also one of the things which is actually going to prepare uh, uh, humans for a future journey to Mars. Uh, and I'm sure you must have all heard about this as well. So Perseverance carries a small helicopter called Ingenuity. The idea with the Ingenuity was, like doing some demonstration on powered flight on Mars. And after few successful flights, initial few flights, then like it completed its goal of the Ingenuity flight. Then they decided to continue doing more flights of the Ingenuity helicopter, and use the helicopter as a scout. So the idea is, the rover, it will take some time for a rover to drive from one point to another point, but the helicopter can relatively fly faster, and it can take pictures. So we can take pictures from the helicopter, and we can see like where like which are the places we want to go. Um, so that was all about the rover, like a quick overview of the rover. Now I'm going to go over the instrument MOXIE. So MOXIE stands for Mars Oxygen ISRU Experiment. ISRU stands for In-Situ Resource Utilization. So I'm going to come on that after a few slides. So with MOXIE, the idea is to basically produce oxygen using the carbon dioxide from the Martian atmosphere. Okay, so let's see. So one might think, why do we need oxygen on Mars? So, of course, like for astronauts to breathe. And the second reason is for bringing them home. So again, like the question might arise is, why do you need oxygen for bringing them home? Uh, because when we actually, like from our like by coming back, we will have a rocket, and we will need oxygen to burn the fuel. So here's a very simple experiment which I think you might have done it, or if you haven't, then you can try that. So this experiment is to actually show that oxygen is required for burning. So what you can do is you can light a candle, uh, let it burn for some time, and then after some time cover it up, basically put a glass on it, and then after some time it would basically it will get turned off. And the reason for that is because you have put in like like the glass on it, you have covered it, so there is no oxygen, there is no sufficient oxygen, and that would kind of make the candle light up. I'm sorry, it will turn it off. So again, like the idea is, for burning something you need a fuel or an oxidizer, and here the oxidizer is oxygen. So again, like one of the ways you can actually have the rocket like get the oxygen is, you can get a lot of oxygen from here, from Earth to Mars, but that can be very costly, because like as the number of people increases, like like for a crew, you will need a lot of oxygen, and for bringing that oxygen from Earth to Mars, you will need a lot of money. So for that, uh, we just discussed, or we just like saw earlier in the slides, that Mars has 95% carbon dioxide. So one of the way what we can do is there is a term called in-situ resource utilization. So in simple terms, you basically use a resource to create another resource. Okay. Another simple way to understand this is, let's say you went for camping, but then you forget to bring the wood with you, but then you want to light fire. So what would you do? The simple way is to like hunt for like small like food pieces here and there, and then just get that and burn it. So that's the idea here. So so MOXIE is an instrument to experiment to verify and validate the technology of my ISRU, or to put it in simple way, validate that the like we can take the carbon dioxide from Martian atmosphere and convert that into oxygen. Another simple way to understand MOXIE is kind of like a tree. It takes in carbon dioxide and it produces oxygen. Here's what it actually looks like from inside. So one of the part is called the SOXY, or which kind of does the like the process of splitting the carbon dioxide into oxygen. And there is a motor and there is a pump which kind of sucks the Martian atmosphere. So this is how MOXIE looks like from inside. So we have the sensor panel, we have the scroll compressor, we have the SOXY assembly, or which is the heart of MOXIE, which does the electrolysis, which does the chemical reaction. So basically what it does is it basically at first MOXIE heats up to 800 degrees Celsius. So we heat it up like really hot to 800 degrees Celsius. Then it collects the thin carbon dioxide and then it filters and it compresses it using a pump. And then we pass that to the SOXY assembly to produce oxygen. For now, we just measures the purity. I mean, like how much is the carbon monoxide and how much is the oxygen, and we just discard it. So I have got few pictures of how does MOXIE really looks like from inside. So this is how it's actually packed inside the belly of the rover. Then with all the other instruments, and this is the filter, which kind of this is the outlet where it gets the it sucks the carbon dioxide from Martian atmosphere. So this is I like operating MOXIE is one of the very interesting thing I have like enjoyed doing. So maybe so okay, like I'll go through that quickly here. So one of the important thing while operating MOXIE is we want to make sure that we are not breaking MOXIE on Mars, because let's say if you break, then there is no way going back and like fixing it there, at least for now. Uh, so we have a model, or to explain in a simple way. So MOXIE is like like there is a software model of the entire MOXIE. So by software model, what I mean is everything is just like like uh, modeled, or like we kind of simulate that on computer, and then we make sure that before sending any commands, we run the simulation, and then we make sure that it's basically it's not breaking, or it's getting it's doing the thing we want it to do. uh, Another thing is, so there is a similar uh, like one MOXIE is on Mars, and there is another the model which is called as engineering model. So this is here on Earth. So again, like the idea is to run it on this as well, to see how does it perform, and like get the before actually doing more experiments on the engineering model as well, to understand more of how does the entire system works. So one important part of operation is uplink and downlink. So uplink is when you actually send the commands from Earth to Mars, and downlink is when you get the data from Mars to Earth. Um, and during downlink, we also have an orbiter which kind of sends so basically in downlink, the rover sends the data to orbiter, and then the data orbiter sends the data to Earth. So here is what generally MOXIE run process looks like. So we kind of define an objective. So one of the objective is, let's say, produce oxygen on Mars. Then we run the software model or the simulation. Then we run that on the engineering model or the hardware or the MOXIE, which is here on Earth. And then we run it on the test bed, like the flight software test bed. If all is okay, then we deliver the sequence to Mars, which is again called as uplink. Then we run the thing on Mars, then we receive data from Mars, which is downlink, and then we analyze the data. And that's a typical MOXIE run process looks like. And so MOXIE demonstrated the first ever production on oxygen on Mars on 20th of April. So again, like it produced around 5.37 grams, which is sufficient enough to keep an astronaut alive for 10 minutes. Sorry, for 10 minutes. And again, like when MOXIE generated the oxygen, there are so many numerous sensors, or there are so many measurements we took, and then after measuring everything, we just exhale out the oxygen and the carbon monoxide back into the Martian atmosphere. So what's up with the Perseverance rover right now? Where are we? So let's see. So this right here is the map of where the rover right now is. This is where the rover landed. This is where the Ingenuity helicopter is. We are currently on Sol 236. We drove around 1.62 miles. Total MOXIE runs are 5. That means we produced oxygen for 5 times. Ingenuity made total 13 flights. And the samples I was talking about, that make a hole in the rock and then collect the samples and put that in a test tube, put that in a tube. So we have collected total 2 samples so far. There is one more thing I wanted to talk about here is the solar conjunction, although it just ended on October 14. But basically what happened was from October 2nd to October 14, if you see in the picture, Earth and Mars were direct opposite to each other, and Sun was basically in between them. So during this time, we couldn't actually communicate with Mars. I mean, we could still get the data, but sending the commands from Earth to Mars, there were very high chances that the radiations from the sun would actually could miss a lot of data. So all in all, we didn't actually send any data to rover during this time. So all of the orbiters, all of the landers on Mars during this time did not receive any data from Earth during this time. But we were still getting the data from Mars to Earth. And again, like the reason we were getting data, because let's say if we lose any data, then we can always request the data back from the orbiter or from the rover. But the reason we don't send the data during this time is, let's say if you send something, like you ask the rover to picture a rock, but let's say if something that command got lost in between during the transmission, and let's say the rover got a command saying that like just drive on this rock, so that could actually break things and we wouldn't know. So again, like although the solar conjunction is over, but I thought of actually mentioning this here. And then to end up the March 2020 and the Perseverance and the MOXIE talk, I have got like few pictures. So these this is one of the 3D images which the Ingenuity helicopter took. This image shows the rock where we got the first sample, and the picture above at the top, they are showing the sample inside the tube here. And this picture on the right side, it shows the Ingenuity helicopter flying and its shadow on Mars. So with that, I'm going to, let's see, we still have half an hour. Okay. So with that, I'm going to transition to the James Webb Space Telescope. Okay, so the James Webb Space Telescope is scheduled to launch on December 18, 2021. Again, like in this presentation, we'll see what makes the telescope very special, and what are we actually expecting to learn, or learn more, or what are we expecting to learn from the telescope. But before doing that, I would like to thank the Space Telescope Science Institute for actually providing the slides. So all the slides I'm using for this James Webb Space Telescope, they have been provided by the Space Science Institute, Space Telescope Science Institute. And the resource document, I have also linked all these slides, the James Webb Space Telescope slides to the resources. Okay. So basically, we over the period of time, like since 2000, since 99, like we have NASA has launched like the series, like a series of space-based observations to study different wavelengths of light. So the Spitzer Space Telescope was it was in operation between 2003 to 2020. The Chandra Ray Observatory is in operation since 1999, and Hubble is also in operation since 1999. One thing here is, so maybe I'll go through that in later slides. So like, what does the visible and near infrared mean really here? So so basically, like we with each additional space telescope, we continue to learn, like the incredible amount about the universe. So now the telescopes observe different type of lights. So and that kind of gives us the unique perspective of objects in space. So like in this case, all these are like the nebula and the galaxies. So these are all the different like images taken by the like the different telescopes. Oops. So we actually, so all these images, so this is kind of one of the, I think, famous images from Hubble Space Telescope as well. It's called as like staring deeper into space. So what they did was in 1995, Hubble Space Telescope was just pointed, it actually just pointed the telescope at a single point, and which was like nearly empty patch of the sky. And they did it for 10 days. And then after 10 days, it combined, when we got the data, when scientists and engineers got the data, they combined all the images, combined all the data from all these numerous observations that were made during these 10 days, and they constructed this image. So basically, what we see here is when we thought, okay, like that's very, like an empty space, that's a black space, but that wasn't really a black space or empty patch. That has like numerous small stars or galaxies. So yep. So so basically, the James Webb Space Telescope, it will basically discover more amazing. It will also like deliver more amazing science. It will, it will see which which has never been seen before, and it's kind of complement to like all the discoveries made by all the other telescopes so far and different space missions. Um, So one thing which the James Webb Space Telescope makes very special is the James Webb Space Telescope is actually going to work in the infrared region of the visible spectrum. However, the Hubble, on the other hand, is worked on the visible light. So let's see what that means. But before going that, uh, this is one of the graphics showing the very early design of the telescope, and just for context, so this design, like scientists and engineer, like they started planning for like the more advanced space telescope back in 1989. And just for context, the Hubble was launched in 1990. So now if we see like maybe like something which is really to appreciate here is the work on this telescope. Actually, like the plan on this telescope began in 1989, and we are here in 2020. So it took that long time to like to plan and design and to to manufacture such a advanced telescope, and like work of like many numerous people to like who has worked on this telescope. So why basically we study infrared light? Or so here's an example, very like like a very simple example. So in visible light, this is what we see. So like humans, like we actually see things in visible light. So this is the crocodile. So this is how we will see. But in the infrared light, we would see basically something like this. So in infrared light, we see completely different details. So the meerkats, they kind of glow here dramatically, and that shows like uh, some special characteristic about their body. The crocodile here, uh, it is like brighter than the cool ground here. So this part is cool ground, and this is the crocodile. So this is brighter than cool ground, which kind of tells us that like it has been recently in the warm water. So to put it in different way, we can also like consider the infrared pictures in infrared light is basically like things that emit heat. So that kind of glows very differently in infrared light. So let's say if let's say humans had the infrared vision, we would basically see something like this as well. So let's say someone like in the night, so we wouldn't see anything dark. We would see something like this because our human body continuously like it emits heat. So based on that, we would see something like this. Well, I'm glad that we don't see infrared light. We only see the visible light. But scientifically, having infrared light kind of help us understand a lot of things which we wouldn't otherwise in visible light. So as I mentioned earlier, so the telescope specialization is in infrared light. So anything which is basically starts beyond the red color here, that falls into the infrared region. Okay. So again, like with the capability of actually observing in infrared light, the telescope will be able to see what's behind the dust, or that dust we see everywhere in the universe. Or um, so what does like each type of light show? So in visible light, forming stars are inside dense cones of gas and dust, so which blocks their visible light from reaching the telescope. So Yeah. So basically, like the gems, like the telescope's image, help us see like past what's behind the dust, and like figure out what's going on in these dense region in very great details for the first time. So here's a very simple example of like how like let's how the telescope what the telescope can see. So here we are starting here with the very early universe. So when stars begin forming and then heating gases, then after that stars assemble into galaxies, then galaxies become more massive, and then we kind of see the clear universe of reionization. So again, like with the infrared power of the telescope, it can actually peer deeper into space and capturing some of the very first galaxies that formed when the universe cooled down after the Big Bang over 13.5 billion years ago. So, so basically, like the idea is when actually light travels through the vast space of universe, it actually light stretches. And when the light stretches, it basically stretches into longer wavelengths, and that's called as the redshift. And that's the reason when light from the stars that is emitted as ultraviolet and visible light, which Hubble sees, so it's stretched to the longer wavelength and of infrared light. So basically, the light which is coming from very distant stars and galaxies, they since that's already converted into a like that's an infrared light now. So it's very hard to we cannot basically see that in the visible spectrum. So that's what the Webb will capture, and how it can observe extremely distant galaxies. So again, like it would discover some of the very first galaxies created in the past. Um, or I would also say that it's kind of a flip book of galaxies over time. Uh, Another thing we would be able to do is to actually dissecting the black holes. So we will study black holes like the in more details with the Webb Space Telescope. Um, as I already mentioned, so how stars formed, how they live, how they die. So we will actually get to know about that again with the help of this telescope. Uh, Detecting the molecules in the star forming region, uh, including the small, like the small particles which are shown here, and de-examine our solar system planets. So it will also explore planets in our solar system, and like we can gather more data about the planets like Mars, Jupiter, in near infrared light. Uh, and it will also help us when like so this is also like one of uh, the step towards human exploration on Mars. So the Webb will help us understand like the Martian atmosphere even more better, so we can like we can map the cold structures of the other planets like Jupiter and Saturn, and we can study like the seasonal weather and climate, how the climate is actually changing on these planets. Again, like to retread, infrared light helps us find distant planets. So let's take a look at how like like the about the telescope. So it's like one of the powerful and technologies, like it's one of the innovative and powerful technologies that had made the James Webb Telescope possible. And it includes like specialized optics and specialized mirrors and the detectors, and it has different coolers, like to keep to keep the temperature, to keep the telescope very cool. So let's see. Okay, so one of the major part of the telescope is the mirror. So here is a comparison about of the mirrors of the Webb's primary mirror with the Hubble Space Telescope mirror. So Hubble has around 2.4 meters or 7.8 feet diameter mirror. However, compared to Hubble, the Webb Space Telescope has 6.6 meter primary mirror, and the reason we want to have the bigger mirror is so that we want to capture like high resolution or like Hubble-like details in infrared light. One thing you might have noticed here is the mirror here are hexagonal in shapes. Their segments, they're 18 hexagonal segments, and they are hexagon, like they are in this shape because so that the mirrors can, you know, like adjust to align without gaps and form a circular shape. And this shape also helps to actually completely like fold the mirror while during the launch. So let's see. Webb, the telescope has 4 scientific instruments. So let's see all of them quickly. So one of the instrument called is NIRSPEC. So it's like it's a tool for, you know, like near infrared spectroscopy. So one of the coolest thing about this instrument is it can actually you know, like it can work as a micro shutter array. So all the different parts of these, you know, like it can capture individual spectra of dozens of objects at once. So that makes it very efficient studying in many distant and faint galaxies. The other instruments are the NIRSes, NIRCam and MIRI. So NIRCam is the primary imager or camera. So it kind of helps in delivering high resolution imaging and spectroscopy for a wide range of investigation. So where it has been placed. So the telescope is going to be placed at a point called as L2. So this is basically this point is beyond Moon, and the reason it is basically placed here is so that it can, you know, like this point is balances the gravitational force, gravity from Sun and Earth. And this point is approximately 1.5 million kilometers, or, you know, like 930,000 miles from Earth. And the reason it is kind of, you know, placed at such a distant location is because, let's say if it has been placed somewhere near Earth, then all the heat from Earth, Moon, and Sun would have actually blocked us to do like more infrared measurements. So that's the reason it is actually placed at L2 location, where it has like you know, like it is not obstructed by, or not like really obstructed, but it is not like affected by the heat and from Earth and infrared light from the telescope. Here is how the telescope look like from top and bottom. So on the top, it has the primary mirror. This is the secondary mirror, which secondary mirror. The science instruments are behind the primary mirror. It has the multi-layer sun shield, which kind of protects to actually, which basically like keeps the upper part of the telescope very cool. At the bottom, it has antennas that communicates with Earth. It has the solar power. It has the steering and control, and it has the star tracker for constantly getting its direction and, you know, like maneuvering it.
Piyush,
yep.
Excuse me, can you hear me? Oh, we kind of have reached the time where we're going to do a really quick little raffle prize and then open it up question and answer. So if you kind of want to wrap up a few final thoughts here, and then we'll go to that, if that's okay.
Sure. I actually have just 2 more slides.
Oh, perfect. All right.
Yeah. So one quick thing here is you might be, like wondering if this is a huge telescope, then how it's going to be like launched. So the idea is actually to fold it, and there is a video. So maybe in the interest of time, maybe I'll just share the link to the video later. But the way it's going to be done is once it is folded on Earth, then we will slowly in different steps, we are going to unfold the mirror, we are going to unfold the sun shield, and then deploy it completely. So I will actually post the link in the chat uh, afterwards. So let me actually. Okay, never mind. And how we are going to talk to Webb is via the Deep Space Network, and the same Deep Space Network you use for communicating with Earth, with the Perseverance rover as well. And last but not the least, it's an international collaboration. So it has been actually since beginning, in addition to the United States, 14 countries are involved in building the telescope. And that includes Austria, Belgium, Canada, Denmark, France, Germany, Ireland, Italy, the Netherlands, Spain, Sweden, Switzerland, and the United Kingdom. And NASA is the lead partner on the project, and it's working in collaboration with ESA and Canada, the European Space Agency, and the Canadian Space Agency. So again, like the point of like showing this slide is like it's such a huge project that it kind of needed collaboration. It's a huge teamwork of like 14 different countries, and with so many people working together hand in hand, to like to get to build such a a huge telescope. And that's it. With that, I would like to end the talk. I hope you enjoyed it. I hope it wasn't like just me talking. So I hope you enjoyed it. So maybe after the Raffle, then maybe we'll open the floor for questions. What do you, Anne? You're muted.
Yeah, and you're muted.
Thank you. What we will do is have a raffle prize session here, and then we will open it back up for question and answers with you, Piyush. But that was fascinating. I had no idea what else was going on now. And so with that, what we're going to do, I'm going to announce what the prize is. In fact, can I share my screen, Miss Amanda? Is that okay? I'm going to continue. I'm going to share my little screen. And so can you see my screen with the prizes? Amanda? Yes. All right. So the first prize we have, as you can see here, is a solar system for kids. It's an astronomy solar system model kit, planetarium projector with 8 planets. And so Meredith is going to do a little spinner and tell us who's going to win this prize. So if your name is called, we're going to give everyone 30 seconds to be able to respond and put their name in the text and say, that's me. And what we'll need is your email address so that we can contact you about picking the prize up. So with that, I'll put my timer on.
All right. You want me to, so for this first prize, the random number I had, which is based on the RSVP response sheet, is 30. So if Sarah Abramson is here, if you want to let us know or send it in the chat in the next, I think Ann said 30 seconds, we'll be able to get your information and get your prize to you, or you'll be picking it up on campus, I believe. Is that right, Ann?
Right. We'll have it through the Welcome Center. And so you can just put it to the panelists, or yes, you don't have to do it to the whole.
Well, I'm actually, we can see if they're here in the attendee view. So, okay, not yet. So I don't think they're here. I'm going to put it 1 through 30, and here we go.
2 people raised their hands. I don't know if I can't see anything but my screen.
Okay, I'm looking and I don't see a Sarah joining unless there was under a different name. All right, if that's the case, then we're going to keep going. Number
Okay.
22, so 1, 2, 3, 4, 5, 6. So Lindsay Shea, who I see is here, will be the winner if you're still on, Lindsay. Let me see. Okay, Lindsay's here, so that's perfect. So Anne, are you going to be updating the sheet, or will you
Yes,
be
we
able to just put winner name? And then Lindsay, if you want to
Yes.
just add in your email in that private message you sent, that'll be perfect. And I will pick the next winner.
Lindsay Shea was part of our class that pulled together they were the ones who looked up the raffle prizes. And
Oh, congrats, Lindsay.
Yes, thank you,
Right.
Lindsay.
So for the second prize, Anne, do you want to scroll down so they can
Yes.
see?
The second prize is Star Night Light for Kids from Elm Tree Universal Night Light Projection Lamp. And so it projects the stars to the sky.
All right, and so this number is, and I see the name on here is Jason. So Jason, if you're still here and if you're still on the Zoom, please send us the private message in the next few seconds, and then we'll move on to the next, and I'll generate another number.
Jason had his hand up the whole time. So
Oh, good. Maybe a question for our Q&A soon.
8 seconds left. The only reason we time it because a minute is a long time for everyone to wait for someone to show up. So Jason, are you still there, sir? Oh, okay. Well, okay. Can't, there we go. Well, I guess we'll try another person.
Okay.
Did he respond? I can't see the chat.
Yep, I don't see anything yet. Another thing we could do is circle back to this. You could put temporary Jason. Okay, Jason is here. Yep, so all set. Jason, we saw your message.
Great.
If you want to also add in the email, we'll put that together for you soon.
In later. Yeah, we'll put the emails in later. Okay.
Okay,
The next one is, okay, so the next prize will be an Orboot Mars interactive globe for planet Mars. So this is really cool because if you hold the student who found this was really excited. If you hold your iPad up, it actually will tell you what you're seeing when you're walking around through Mars on it. And so anyway, who do we have for that?
So this winner is
Okay.
Allison Russell. Congratulations, Allison, if you're still here. Yay, perfect. We got the message. And same thing, Allison, if you want to send in the email, we'll check on it after and we'll update our notes.
Right. Okay, so the next prize we have is a Green Science Solar Rover, a kids do-it-yourself solar power eco-engineering STEM toy. So who do we have for that?
We have Kelly Halloran. Kelly, if you're here, let us know, and the prize is yours.
Let's see. Kelly? Is Kelly in there?
Kelly's here.
Oh, do you see, did she respond?
Yes, we got the message from Pete, so I don't know if that's in the same family or friend group that's watching together, but same thing, we'll get the email and we'll get it over to you as soon as possible.
Okay, so Kelly, what's the last name?
I think it was, I'm sorry, let me go find it again.
Well, we'll find, she'll respond. Okay.
Thank you, Pete.
All right.
Okay.
All right.
The next person we have is Mikey Meehan.
Okay.
So Mikey, if you're here,
let's see here.
What was their prize? And I'm sorry, I don't know if you explained it.
That's okay. So the solar system floor puzzle. So a solar system floor puzzle. And so Mikey, if Mikey's here.
Yep, we got the message. Mikey's here.
All right, Mikey. And then I hope I spelled that right. That's Mickey. Just a second. Let me do Mickey. There we go. Okay. And then foot traffic, kids novelty sock with planets all over it.
Okay. So this is the next prize, right? The socks?
Yes.
Okay. Oh, we got it. Thank you, Kelly. Audrey McQueen, you are the winner of these amazing socks, if you're still around with us.
Are you still here, Audrey?
Here. Perfect.
Another one in my class.
Oh, great. Well, welcome.
Okay, cute. And then we have two more prizes. A rocket ship play tent, pop-up play tent. Oh, getting rid of my thing.
All right.
Outdoor
this winner-
playhouse tent.
This winner I'm seeing on the screen name is two people in one. So Daniel and Sammy. I don't know if you're still hanging out with us. You are the winner, if so. And we'll
Just keep
see
it
if we
here.
get your message. Daniel and Sammy, are you here? We are here. Perfect. Great. Send in your
Oh,
email
yay.
and we will be all set. How many more prizes do we have, Anne? Last one?
Last one. Then we get to questions. All right. Brick
Right.
by brick space, 20 Lego brick projects that are out of this world. It's a book.
All right. This is the 30-second timer. All right. So the number. All right. So this winner is Debbie Green. And Debbie, if you're here, you are our final winner. Congratulations. That's me. Okay, perfect. We have a response.
All right.
We'll get all the emails after the Q&A, and then Anne will take it from there. But thanks for playing along and hanging out with us. We hope you enjoy your chances to win. All right.
Exactly.
So now
So-
we are all set for you, Anne. And
Yes.
Pardon.
And so let's see what questions we have showing up. Just put the questions in the chat. I see some people with hands up. Let me see if they're still out. 3 participants have their hands up. So let's see. Can we get them to ask them?
Actually, I'm really sorry. I saw all the text about the messages about the slides not being completely clearly visible.
Yes. And
Now,
so this, are we
One
talking about the slides being small? Is that what you're saying?
yeah.
So
Right.
we were on the back end working with our IT department. If the slides did appear a bit small, it might have been if you're using an iPad, which is something that our IT department just submitted a web ticket for to see if we can fix for future use. Something else to know is we're recording this entire show. So I'm going to be downloading it and converting it into a YouTube video that can be accessed on the Moon over Merrimack 2021 Google site. And so you should be able to then see the slides at a larger view. So you can just keep an eye out on that Google site, and hopefully if there was an image that you really wanted to see, you can zoom through and just look at the slide at a larger view. But thank you for bringing that up. I wanted to mention that.
And thank you all for your patience with that. I know it would be frustrating if you could only see the little screen, but we will be able to see it on the YouTube, the recording. And so now with that, questions for Piyush. See the chat. Where I know we have questions. There's a Q&A. How do we access the QA?
We just got one, so we'll answer this one live. An anonymous attendee asked, can you describe the process you went through to secure a working with NASA?
Yeah, so I don't the Solar System Ambassadors program, so maybe I'll talk about that. So I'm part of the Solar System Ambassadors program that is run by NASA. So they open an year-round application. Well, sorry, year-round means run through everywhere. No, sorry, I lied. So the application opens sometime in the September. So you basically apply. There is a little application. So you basically apply through it. And then if you get selected, then you become like one of the solar system ambassadors. That has like a lot of benefits, as in like you get to learn a lot of things. So all these you get to attend like all the trainings on different missions. And then because this is we are still doing all these events over Zoom, but there was a beautiful time when I used to visit planetariums, and that's where how I first met Anne in WPI. So I used to go in person, and then you, as a part of the Solar System Ambassadors program, you get all the handouts So like all the cool stickers, posters, so that we can, like distribute during the events. So that's how, like, if you want to part of the Solar System Ambassadors program, you can apply there. I can actually post the link to that. But yeah, that's pretty much it. But again, like as a solar system, the Solar System Ambassadors program is just a volunteer program, so we are not like really employed by NASA. Neither my involvement with MOXIE is employed by NASA, so that's something I volunteered in my free time with the MOXIE team. So yeah, but like the Solar System Ambassadors program is something which I find like really cool and exciting, because I'm passionate about space, and that's one of the ways I can, like spread my passion of space exploration with everyone else.
Oh,
I hope
beautiful.
I answered. I hope that answered your question.
So we have another question from an anonymous attendee that says, what happens if something on the Perseverance rover needs to be fixed? How do you go about fixing that?
Really, I mean, like it depends. So let's say maybe so like if one of the instruments inside the rover is, like broken, then it's not very easy to fix it. Let's say if the computer breaks, then there is a redundant computer. So there are two computers on board. So if, let's say, if one computer stops working, then you can switch to another computer. But let's say an example, God forbid, if MOXIE breaks, uh, it's basically it's done. I mean, like there is no way we can actually go on Mars and fix it. But like for the Spirit and Opportunity rover, which are on Mars, they are not operational anymore. But let's say sometime what happens is, like if the wheels get stuck in the ground, so engineers here do like a lot of experiments to try to see like how to, like get it working. So those kind of things, I think that can be with some experiments and with some new things which we can try here. But hardware wise, if something, like fails, if there is no redundancy, then it cannot be like really fixed there.
Someone said no questions, but thank you for the time to show us these slides.
Sure,
Yeah.
I'm glad. I'm glad you liked it.
Yes. Okay, so do you see any other questions? Let's see if there's one in the chat. Anything in the chat?
Yeah, let me quickly post the link of the Solar System Ambassadors application.
Oh, and for the folks still on, we put together a list of books in the Merrimack Valley region in the Noble Library System that are related to Piyush's discussion here tonight. We also put together a list of resources that links to more information on about every aspect of his talk that we could find. And Piyush actually added a few more. And so do you want me to add this one to it too, Piyush?
Sure. Yeah, you can
Yes.
do that too. Yeah.
Okay, so I'll put that in there as well. And so both of those are located on our main Merrimack website where you went to register for tonight. And so if you got this link from the STEM website and you didn't get to the main Moon over Merrimack website, let me know and we'll post that website link so that you can actually see those resources, because a lot of work went into it from people all over campus. I could think a whole bunch of people that made that come alive. And so with those books, you can check out and get through interlibrary loan at any point. And so
yeah, they're
yes,
posted on the Google site, the Google Moon over Merrimack site as well.
Yes, definitely. And for those of you who won prizes, be sure you put your email to us in either the Q&A or the chat, and we'll be able to get that for you. Yep. And so we really appreciate everyone coming tonight. And Piyush, thank you for the time you put into creating the presentation, as well as sharing so much vast knowledge of your passion. It just spreads throughout the Valley, and we really appreciate it. So
thank you so much for having me, and thank you to everyone for attending and your time.
Yes, thank you very much.
And if any other questions rise up, you can always email our SCSP Dean's office email that sent you the registration link and the login details or email Anne directly. We can add our emails on the Google site if that works. So yeah,
Yes.
thank you all
So,
for coming.
thank
All
you.
right.
Oh,
Good night.
good
Good night. Good
night.
night, everybody.
Bye-bye.